Did I get the right number? Oh well, close enough. People will figure it out. Whew, welcome. This is an incredibly exciting episode for me because I'm going to try and explain the Swan language. And this has always been difficult because there's a wonderful phrase called inferential distance. Have we talked about that before?
I think we have.
But let me just review it. The basic idea is that if you're trying to explain something with words, you have to start with words that the person already knows and then lead them to infer something else from there. So, and a lot of our culture, especially on the technical side, is all about words. The problem is words have to be grounded in an experience. And if your experience of the word father or computer has a certain set of associations with you, then it's really hard. You can only take them a certain inferential distance just by using words. And some chasms are uncountable. Like, it is impossible for me to explain to my son why he will want to get married someday. It's just, he's 6 years old. He just has no grounding of those kinds of urges or drives or concepts. And this has been my problem with this approach to programming that we're talking about, is that it is just so foreign, and it basically redefines and undefines so many concepts that people who know nothing about programming think it's cool, but they have no real basis for understanding why it's cool or what it matters. And people who do know programming find it somewhere between insane and impossible. And so I'm so excited to be able to explain this to you because we've had this massive shared experience of the hour of node process and code base and document-driven programming. And we've had, over the last week or two, several interesting and probably frustrating exercises trying to implement bits and pieces of it. So I'm hoping we can do is just sort of do a level set, mulch all of that experience, and then try and explain it to you. And have you push back on what's not clear and what doesn't make sense. And the goal is that at some point, it may take several days, you'll understand it well enough to actually build it. Right? That is the constructivist approach to learning. You don't really understand something until you can build it yourself. And so it's the perfect test case because you'll be asking exactly the right kinds of questions. So I'm really excited. And even though we just finished our devotional, let me just start by praying. God, I am just so grateful for this opportunity to just spend this time with Daniel, sharing what's on my heart. I pray that I would listen well to you, to him, to myself, and that I would be able to articulate things clearly and at an appropriate pace to give Daniel the opportunity to digest and assimilate. Help me as much as possible to make this not about me and about my ideas, but about us and the thing that we are trying to create together. I've failed many times at that, and I want to learn how to do better. And I pray that this would be a cornerstone for, God willing, everything we do going forward. I ask this in Jesus' name. Amen.
Amen.
Alrighty, so I did start hacking up a little wiki page to give us some context. And so let's start with that. Hide this. Let's actually go into presenter mode so you don't lose the screen. Okay. So the first thing, like I think you asked me yesterday, was, is this a language or is this just a way to do simple data flow? And the answer is yes and no. Yes to both, no to both. And the phrase I'm working with now is calling this a programming format rather than a programming language. Do you have a concept of programming apart from language, Daniel?
Maybe that seems like an odd question, but at a higher level, I think that syntax is mostly you can I think that programming is problem solving and learning how to get logic and problem solving into if statements, and that what language you use to do that, is relatively unimportant relative to an individual's ability to think like a programmer. I don't know if that answers the question.
No, that's fair. And I think the so let's just dive into this. So the idea of the Swan programming format, and I'll go with that name because I think that's at least comprehensible and draws a fair distinction, is that the basic premise is that the entire metaphor of programming language was a bad idea. I mean, it was a reasonable idea at the time, but and I think the reason that we obsessed over languages as a way of doing programming was the idea that we're trying to represent human intelligence, and therefore we should try to represent, and we think in terms of language, at least we think we do. So that was kind of the basic concept that all this stuff flowed out of. And I guess in the 40s and 50s, when all this stuff was done, they were very optimistic about artificial intelligence, right? If we just create the right language, then we could express reason and we could think like people. And AI, went into a kind of a slough of despond in the 80s. It's kind of coming back in interesting ways. But what we're trying to do is basically a level set. It's like, wait, we spent a lot of energy over the last 70 years or so really thinking about languages and syntax and grammars, and there's a whole set of machinery, not just technical machinery, but educational machinery built upon that. It's funny, when I ask people, you remember your syntax from when you studied computer science? They say, yeah, they can run off the different kinds of parts. Do you remember your semantics from when you studied computer science? And they all kind of give me this embarrassed look. Like, as far as I can tell, nobody remembers the semantics because it's all this weird mathematical gobbledygook. Anyway, so what we're trying to do is kind of what you're talking about, except without the if statements. Right? The thing is what is the fundamental conceptual basis of what computation is, and how do we express that as simply as possible in the simplest possible data format that will describe those concepts.
Mm-hmm.
So the first list is, so there's no grammar, all these complicated grammars and syntax. There's no keywords, there's no if, there's no while. There are operators. There are predefined operators, but they don't really have any special treatment by the language. There's no globals. I mean, there are things that are at the root of your hierarchy, but my understanding of a global is a thing that it's always global wherever you reference it, and you can't override it or hide it. It's not just parent scope, and I don't believe in globals. It's part of the whole humility. Only God knows what is ultimately real. We just have contexts that we understand more or less perfectly. It's also, globals are the source of most pain in programming, as you probably are aware. No reserved words either, at least a priori. I may renege on that if it turns out to be a usability issue, but to start with, I want to just get everything is up there, and if you have a reason to redefine it that you think is valid, you should be able to, at least for your own self. And the other thing is no special forms. Like, a lot of Lisp people will say, oh yeah, we don't have any of this stuff either. But Lisp has a ton of special forms where they munge the syntax of the language and the interpreter to handle special cases for all sorts of things.
Mm-hmm.
And the goal is to get away from that and say, can you make things that's really simpler and more consistent than Lisp? But one of my mantras is that most programming languages are really bad document formats, except for Lisp, which is a really bad data format. And so we're going to come up with essentially a better data format than Lisp. So this is where I put on my, I will suspend humility and modesty for the duration of this call, just because otherwise all the caveats would take up everything. A priori, yes, this is megalomaniacally arrogant and insane and overweening to say, yes, everyone's been doing this wrong for 70 years, I'm doing it right. I acknowledge that. There is a very good chance I'm fundamentally flawed at some deep level, but I'm just going to go with it for now and see how far we get and invite critique and ridicule later. You down with that?
Yep.
All right. So the idea is that most people, when they design a language, they talk about the syntax, they build the syntax, they build the parser, and I think that's completely the wrong way to think about it. So the real thing is to think about what is a language, and what do you actually want to build for? And and I'm still trying to figure out the right set of concepts and the right ways to describe them. But one of them is scope. Is that scope, I think, is central to the concept of programming, which is why there's no globals. And you really want to have a really good mechanism for managing scope, and just acknowledge that it's everywhere. And just the second thing is having consistent evaluation rules. That's why there's no special forms. Everything's just a fold, basically, and grouping. Fold and group. I guess group and fold. The other is generalized abstraction. One of the funny things is that everyone talks about how programming involves abstraction and finding the right abstractions. I could not find any theory of abstraction. It's never, as far as I can tell, well defined anywhere. It's just kind of assumed as a thing. There's abstract data types, there's abstract base classes, there's abstract this and after that, but there's no this is abstraction. What is abstraction? So I would like an answer to that question. A bunch of special cases. Let's call it symmetry. Can't spell symmetry today. Wasn't that what I typed? Oh, 2 M's. I think that's right. Hopefully I didn't misspell. So the idea of symmetry between code and data, right? This is breaking with the von Neumann tradition and trying to make it really clear that code and data are just different sides of the same thing. And then explicit state management. This is the one thing I think that literally pure programming violently disagrees with. Is they want to be able to operate at the level of pure mathematical functions that have somebody else worry about state. And that to me is the, why instruction sets are evil. The whole concept of an instruction set is you have this abstraction that lets you do operations and somebody else worries about state. And the idea is that you need to be, and so the kind of the general premise is that there's a lot of pain and complexity in programming, and we get surprisingly little out of it. So the goal is to come away doing programming where the really brain-dead obvious stuff just goes away, and you introduce the right pain at the right places. Right? The goal is not to make programming painless, but rather to Does that make sense?
I think so.
Like certain things should hurt, because you should have to worry about certain things because they actually really matter, right? you should need to worry about what really matters when it really matters, not otherwise. So, for example, you should be able to, like, if you really don't care about performance or latency, you should be able to write really simple, clean code that'll perform tolerably on most reasonable architectures. But then when you do care, and be able to, examples, calling conventions, cache coherency, copy on write semantics. Like one of the things, the reason why assembly, why assembly code is faster than C?
No.
When it's up. The times when assembly code is faster than C is that C has an ABI, right? A binary interface that says when you have one function going to the next function, this is what you do. You save these registers, you push this on the stack, you do that. And that is hardwired into the very definition of C. And these days it's hardwired into instruction sets. But when you're really writing, the old school assembly, you don't have calling conventions. You just shove stuff around in registers and jump everywhere you want, and you manually manage that when you care about it. And that's literally impossible to do in C. You can get a little bit of it automated with inlining, but it's just baked into the concept of C that this is a function, I throw the stack away, I push the stack down, and you have to go through all that overhead. And most of the time it's fine. But when you don't want to do that, you have to break syntax and just jump out of it. Cache sizes and policies. There's all these things that massively affect the performance of your application, which are utterly inaccessible in certain languages. And the choice now is, like this. Right now, you must worry about certain things all the time. Never worry about them at all. Okay. Say that. So this is just kind of a rant, but does this give at least just, whoa, where did that go? Does this at least make a certain amount of sense?
Yeah. So.
What questions are bubbling through your mind at this point?
I mean, I guess the thing that's hardest for me to understand is, it's still hard for me to understand. Like, what are you trying to say when you say programming format? If it isn't what's the difference between that and a programming language?
Right. So a language is defined by a grammar.
Mm-hmm.
Right? We don't have a grammar. We just have a data format. So maybe let me define the format, and maybe that's a good next thing to do, is to kind of try this format. So the Swan format is a variation on on the property list popularized next step, and used by Java, JSON, etc. In a traditional property list, there are separate entities for, e.g., dictionary, array, string, number, etc.
Ernie, did you mean to be sharing your screen with me?
Oh, am I not?
No.
I'm sorry.
No, it's okay.
Thank you.
I wasn't sure what you wanted to do.
I pressed stop instead of present to everyone. It had the opposite effect of what I intended. Okay, let's go back to the preview and review this. So the introduction, all the things we're not, and then the kind of concepts. And the other thing is that the way I would like to be able to do this is to first build up the runtime and then layer on the syntax after it. But I think that's just way too abstract for even me to think about it clearly. So we're going to do it the other way around, is we'll define the syntax and build a runtime up to support it. But importantly, we're building a runtime that is designed to evaluate that syntax as efficiently and elegantly as possible. Let's say, sounds crazy, but it will. Okay. Okay. Right. In Swan, there are only 3 primary constructs. There's, let's call it closure, group, expression, and string tuple, which is a boxed expressions. Let's try it like this. Evaluation. 3. Yeah. Start with this. Then we can click on the names. No, sorry. Right. Keep going back on this. No, this should be, yeah, this should be enough. Um, so the idea is, and I go back and forth on the exact syntax mapping and the names, but there's three kinds of aggregates. There are, let's call these three aggregates. Which function is either dictionaries, both, which function, which do function. Does that make any sense at all, or do we need to unpack that a bit?
I think I don't. So I'm having the property list that I think when maybe you're thinking of something else, but when you say property list, I'm thinking of XML because that's all property lists, like the plist files that are all over my computer. They're just XML.
They are XML now,
Okay.
right? But originally they looked more like JSON.
Oh, yes. I've seen those.
Yes.
But I mean, still, like, it's just a data format.
Right, it's just a data format. Right.
Right, you can't program anything in XML.
Well, yeah, XML is a horrible form. XML is a property list plus a whole bunch of other stuff, right? I'm not programming in XML. I'm programming in CSV.
Okay.
JSON.
Right, but you can't program in JSON either.
You can't.
But well, okay, so that's.
We did, right? That was the hour of node. We programmed. I mean, David wrote a game level in CSON, right? Exactly. This is basically what we did with CSON files in the hour of node.
I mean,
we did in rudimentary form.
Right, but I don't know. I guess in my head that doesn't count as programming.
Yes, it was a very rudimentary form of programming. It didn't have a lot of operators or expressions. It did have a few, but they were very rudimentary. What we're going to do now is we're going to fill in the blanks.
Okay. So here's in the hour of node, you could make a level. Okay, I guess there is an issue with using the actual JSON because you cannot program in JSON. You can't put functions in JSON. You can't put anything in JSON but.
I cannot put. Here's the subtle point. I cannot put JavaScript functions in JSON, right?
Right.
I did put programs in JSON. I programmed my turtles with CSON files, right?
Right.
That was a program. It was a sequence of instructions that the turtle would execute.
Right. It was a string, though. Right. Okay.
It was a string or an array, right? We string for our primitives, arrays for our composites.
Right.
Right.
Okay. So you did that. Okay. I mean, I guess so. You can get that far. But I mean, like, you think about what you could actually do with that document, like a game, like a level description. You could do a very small and specific set of things, and you cannot extend, like, you can't actually define functionality in that.
Yes, we did. You could define your own functions. This is a new function which could be called by another operation. We didn't use it very much, but we did, right?
In a level file?
You could, right? You can define, when we defined run and bump as our two functions, or what do we call those? Actions.
Mm-hmm.
And you can define a new action, and you can call that action from somewhere else.
Okay. 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 All right. I hear you.
Yeah. So, like I said, this is why your brain's going to hurt by the end of the morning. Is that all these things that are considered impossible? I believe I have already done, and I need to actually demonstrate that and see if there is some, at the back of my mind, there is this nagging concern that, wait, maybe this is all impossible and I've been deluding myself for the last 4 years. But that's why we're going through this.
Yeah. Okay. Okay. I guess, like, no, it's fine. It's fine. All right.
We got aggregates.
It's an A after the P.
Wait, no, oh, I see. Yeah, let's see. Not autocorrect that for me, does it? Um, um, elements, that's the word, of those aggregates. The idea is that if you want to create something that looks like a dictionary, you use semicolons. If you want to create something that looks like an array, you use a comma.
Okay.
If you want to do it both, that's fine. Something that feels like both, that's perfectly allowed.
Okay.
This is the other. This is the key insight. Virtually every real-world data structure has both a named header of unique elements and a enumerable list of anonymous elements, e.g. HTTP, HTML, file systems, etc. Right? Is that like HTTP, right? There's a bunch of headers and then a long list of blocks. Right? HTML, there's a header with has header of uniquely header of named elements and a set of properties associated with the header and then the body. TCP. Right? All these things have that kind of structure. I've got a bunch of properties of things that are named, and then a long list of, and then a
I don't understand how HTML or file systems are like that.
HTML, you have a header, right, which has named things, which are kind of what you know about the page, and then there's a long the variable list or tree, right? HTML is basically a header with a bunch of properties and then a tree of elements.
Right. Okay.
And then, HTML tags, right? You've got your attribute pairs, which are your named elements, named properties.
Mm-hmm. Did you just disconnect?
Nope, can you hear me?
Yep.
Okay, I just paused.
Oh, okay.
I monologue so much that a pause sounds like a disconnect.
Oh no, my computer I lost your screen and it said you were no longer in the call and
Oh, okay.
yeah.
Oh, you did lose the screen. Interesting.
Yeah.
Okay. So the idea is okay. Where am I? I guess there's an edit button at the bottom, but can't have everything. Okay. In addition, braces and new lines can serve as terminators. Tabs, however, are forbidden and will throw a fatal error. I hate tabs with a passion.
All right.
That was actually the last time I implemented this. I said, okay, the first rule of syntax is that if you see a tab, die. And then after that, we'll add other syntactic elements.
All right.
Okay. Whether that shows us thumb down rather than, oh, I see -1 is thumb down. Interesting. Okay. Then, all right. So then the next piece is identifiers. Everything else is just an identifier. Of identifiers separated by PSN expression. Everything else is just particular types of identifiers. Pause for questions.
I think all I really need right now is just to see an example of what this is supposed to look like.
Okay, great. Oops. So let's see. Versus values. The primary identifiers named are properties. What should we call these things? Yeah, let's try the properties. let's just do them first and then describe what they are. So I'm going to use this syntax using for the input prompt and so okay, so prompt.p1, and then p turns 1. And that reasonably clear?
Yes.
Then then we could have dot q dot x 1 comma dot y 2 is the value, and then
So why is that? Why is that in brackets? Why is that a closure? What is that?
actually that would be probably better to have as a relation. Or, people. Then let's call it dot a. Let's be more explicit. When numbers are just full and first. I think it's 42 to feel like I'm a real geek. We just can do it like this. We don't even need to name these things. Um,
So why do you have an equals sign next to name?
Very good question. Force of habit. I tried using equal to close, and I realized, oh no, it should just be name, takes an argument, sets the value.
All right.
And then you can also reference say equal in 12 division 3 1 minus actually let's probably just do this for now. I don't want to get in math right yet, so let's just save that for later. I'm not sure if that's a good idea, so maybe I won't lead with that here. Yeah. Right, you can define properties that then show up like that. I'm also not sure what the dictionary is there, but actually, let's do it like this. Numbers that, and then this is where it gets a little interesting. External reference. Numbers dot min returns 3. Applying a setter min to a it returns the value of that property. Does that make sense?
It does make sense. Why are we not using traditional dot notation? Not that it matters, I guess. We can do whatever we want. But
what do you mean by not using traditional dot notation?
Why is there a space before the dot?
Just to make it clear, this is an expression. You could do it like that too, because dot forces it.
Okay.
But, okay. It's optional, but emphasizes this is just another expression. Let's see. Let's do this here. Right, so once you control math, just operators. These for values. Not limited on non-alpha. Does that make sense?
Sure.
All right, so this is basically this is a plist with phrases.
Mm-hmm.
Right, we add these, it's a plist with expressions. Yeah. This is a plist with expressions. We need to do programming. Ooh, that's weird. Oh, right. Maybe can't use that pound sign as a in Markdown.
Yeah.
Tell me if there's another language format that would work better for this. Indent. Oh, I should be doing the. All the problem. Yes. Okay. Can I also do it with quadruple space? Yes, there's a 2. Okay. Text. Thoughts?
No, I mean, I think it makes sense. Like, I guess my biggest issue with it, per se, if I had is just that like, and we've discussed this, but really all we can do is export JavaScript objects to use them in a quote-unquote real programming language.
Mm-hmm.
And that seems, frankly, just like super dramatic overkill.
Right, okay. So the question is, what is a program?
Set of instructions.
Okay, I'll give you a different definition.
All right.
In fact, I think I may have a picture of it somewhere. You see that picture?
Yes.
So a program is something that has state, which may be trivial. It takes inputs and a trigger and produces outputs.
Okay.
And my hypothesis is that that is all that a program is. So when it takes inputs, produces outputs, possibly based on a trigger.
Fair enough.
So all that a programming language or programming format has to do is have a way of accepting input, processing it based on certain state, and producing an output.
Mm-hmm.
And that output is either like a string that you show a human being, or it's a signal that happens behind the scenes.
Yeah.
So as long as I can bind to signals or produce strings, I don't really need anything else. There's really nothing else that a program does.
Yeah. No, I mean, I guess I'm not. My issue isn't whether or not this counts as a programming language. It's just that it doesn't
do anything.
Yeah. Right. Right.
Okay. Right. So so then great. This is we're doing frustration-driven documentation, which is a good. So okay. Yeah, I think I'm just going to do format collapsing because I'm going crazy with this. How do I say this as? Swan doc.md. Change it. Okay, it's better. Let's replace 3 with 1. Oh. Not. Okay. Orient separators, white space, samples. Okay. Okay, it's built-in operators. What actual primitive things do you need to do? So there's basically conditional. Right. Are available on every object. Built-ins. So we need something like nil. I guess the leading candidate for nil is the result of evaluating the empty expression. So one returns one, nil. Should we give it a name?
I mean, you're already referring to it as nil.
Yeah, that would be the obvious. Nil, 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 nil. What do you think?
I mean, given that we're...
Hello?
Maybe it... I have no idea.
Okay.
I don't know.
Let's make it nil. Okay. We'll just call it that, but then it'll evaluate to that. So this is just our local thing, so it doesn't have to be part of the language. It's just a convenience here for everything else here. Okay, conditional. Conditionals, conditional operators. So the idea is that most objects evaluate the argument of true and ignore the argument of will does the reverse. Probably talk about evaluation somewhere, right?
Mm-hmm.
Let's just go over these properties because that's what's going on here. Right, maybe let's not call these examples. This is just actually do need something there for this new level. Okay, properties. For I'm sorry, there was a question in there. Oh, evaluation, right? So so something like 2 plus 2 returns just and then actually show something what it returns. Nakedly just returns closure. And if we do add
Wait. Oh, sorry.
if I should define nil first, or if it doesn't really matter what.
Oh, okay. Okay.
Actually, let's do it this way here. Conditions. Put nil here. And Is that reasonably clear?
Yeah.
Okay, and then arguments use as the anonymous argument. So so far so good?
Why? Ooh. So that's just a way of defining a function without actually bothering to reference directly any of the arguments.
Right. It's simpler to introduce the concept that way rather than the other way around. The I think what's actually happening is that I just realized that actually underbar is the same as up. When you apply a to a closure, actually inserts that world that what do we call these things? Do we actually call these things? Do we have a name for these things here? Use that value above it in the hierarchy. So we have magnitude is
So what does that mean?
it means that mag is evaluated in the scope of. Oh, sorry, that doesn't make any sense at all, does it? Let's try this again. In the scope of where x equals 1, y equals 2.
Okay. Okay.
I think that's all there is to functions. You find nil already, right? We're confusing the parser, but I think I can live with that. And then the conditional operator. So all right, now that we have the idea of evaluating, we can say, let's see, something like, yes, not doing these strings. So, exclamation one, question mark. You still with me?
Mm-hmm.
Does that make sense?
Yeah, why? Yeah, I think yeah, okay.
This expression, nil, right, so one is 5. Is greater than 5, that's false. So that returns. That becomes false. False when customer returns false. False colon something returns. that reasonably clear? Still with me, Daniel?
Yep. Yep. Sorry, just thinking about it.
Sure. Okay, let me take a break and let you think.
No, I'm there. Yeah.
Okay. We have too many indentations there, but. And so this is the idea that appropriate operators get rid of the need for and scope. And this is where the power of a monad becomes really important, right? If everything is, I guess really, if everything including nil is an object, then you don't need special operators for if and then. They're just methods, like everything else.
Mm. Okay. Okay.
Note that this assumes that applying nil to anything other than a closure has no effect. Right, because you're playing. That's the thing, is that most languages make these things special forms because they want to have implicit rules about what's evaluated and what's not evaluated. And here, no, everything's evaluated consistently. It's just doesn't hurt.
Okay.
Then the only other thing I'm sure we need is Dataflow Operators. And there might be a more elegant way to do this, but we use and for app and maybe the other way around. App and for reduce. Or really, I think what's a good example of this, but I guess the simplest one is 1, 2. Does that look right?
Yeah.
Plausible? Then trying to remember how I did semantics of reduce to make that coherent. Let's just say
Now, why choose to use that instead of map?
I want to. All these assignments are arbitrary, but thinking of it as a Unix pipeline. When I think of map, I think of I'm calling something once. But I want to be thinking of these things like a Unix pipeline. And therefore, the pipe operator inspires me to chain these things together elegantly.
Okay. All right. Fair enough.
So let's go ahead and copy this into a typo there. So the idea is that this is all you need to have a useful language, modulo lots and lots of convenience functions. It's probably not a correct hypothesis. I'm pretty sure you need to at least reduce. Though I thought I came up with a cool syntax for how to make that make sense, but now I'm not so sure if I can recreate it. So it might be slightly illusionary. But the idea is that if you can iterate over things, I mean, this gives you sequence selection and repetition.
Okay.
Right? Is that you have finite lists, you iterate over them, and you can operate on them conditionally, and and send events and signals. And with more, and there's a few subtleties here and there that I'm still not entirely happy about, but I have at least hacked around them in the past and got a working language.
Okay. Okay.
So what are the questions that are bubbling around right now?
I mean, I feel like this and what I'm looking at is an entirely different, like, this makes sense. Like, you can show me syntax and it's fine. Like, whatever. I can read syntax. I can handle syntax. Honestly, the more confusing part is why you want to write the parser the way you want to write the parser.
Ah, right, yes. And let me rephrase that. The parser is a red herring. Let's stop presenting. It's my contact here. What I want to build is an evaluator.
Okay.
Right, like the metacircular evaluator for Lisp.
Mm-hmm.
Right, I call it an elliptical evaluator. And the idea is the most important thing is the evaluation engine. Right? A way to evaluate these expressions in a nice, simple way that could eventually. The one thing, the holy grail that I've never achieved is writing the Swan interpreter in Swan. Right? I've written one complete implementation in Ruby, one partial implementation in C, but I've never got to a full elliptical value. When I have the full elliptical self-evaluating, self-compiling thing, then the rest is just marketing. That's the thing that I have to build to actually prove that it's smart enough to do that. The funny thing is that once you have the evaluator, the parser is trivial.
Okay.
And is that the parser is just a few dictionaries that you throw into the evaluator? Is that because the way that you do parsing is essentially the same mechanics as the way you do evaluation.
Okay.
And but it's hard to explain the evaluator. And therefore, it's easier to explain the parser, even if it seems pointless. But it is once you build the parser, then you realize, oh, I just do the same thing and I have my evaluator.
Okay.
Is that all these stages, the lexer, the parser, the evaluator, are just interpreting things in different contexts.
Mm-hmm.
And I don't object to trying to build the evaluator first. It's just that it's to explain.
Sorry, I didn't hear anything you said in the last 10 seconds.
I don't object to building the evaluator first. It's just harder for me to explain starting from there.
No, that's fair. It's fair. But again, I guess, like, if the goal is to have a metacircular evaluator,
An
Why?
elliptical evaluator.
What?
An elliptical evaluator. It's different than what Lisp does.
Okay. If the goal is to have an elliptical evaluator, why does it matter at all how we write the first run of the parser?
Because a parser without an evaluator is pretty useless.
No, but I mean, why why am I so confused about how you want to write the parser and the evaluator if the goal is to have an elliptical evaluator or an elliptical parser, an elliptical evaluator?
Right. Yeah. Well, I guess they're all elliptical if we're going to use that terminology. Um, that is an excellent question. And I don't know a good answer to that question. Um, and that's probably what that makes this a good time to break for lunch.
All right. I guess like I think the idea of an elliptical evaluator is great. Um, or elliptical parser. When I say evaluator, I mean interpreter, parser, everything. Like the concept of the elliptical, um, you know, what a compiler.
Well, so there's two different things going on. One is a self-hosting interpreter, right? A language that can interpret itself.
Mm-hmm.
When I say the elliptical evaluator, I mean something very specific. It's this kind of folding evaluation that feeds into a pipeline.
Mm-hmm.
That is, and that folding mechanism is actually used in the different stages. Is that an elliptical evaluator is really the heart of it, but once you have that, it's really easy to build an elliptical parser and an elliptical lexer.
Okay.
So that together, and that's what we have even before we're self-hosting.
Okay.
Right. So the idea is I had this concept for what monadic parsing should look like and feel like, and so the historical derivation is I had this ridiculously simple language, and I tried to use traditional language tools like a parser and a lexer and Yak and a half dozen, like a bunch of different Ruby things, and it just felt so wrong. There was all this massive redundancy I had to keep creating. But it's just like this thing where you just kind of pull it together and you get this coming out. And that took me several months of beating my head against walls till I came up with this design pattern that made everything much simpler and much more. I give it a dictionary and it just pulls it out and does the right thing.
Okay.
And so that's the historical progression. Is it's fairly, and also until you have, so you need to have expressions to feed into the evaluator. You need to have tokens to feed into the parser. You need to have characters to feed into the lexer.
Mm-hmm.
And so you don't have to have the language itself. You just have to have the runtime that can produce those items, so you can build those things. And so anyway, I think we should leave it at that and actually take like a 2-hour lunch, catch up on whatever, and meet up at 1:30 and take another run at this.
Okay.
And I'll noodle on better ways to explain it or build it up, and you can noodle on ideas that might, or like think of a thing that would make more sense to you and see if it's plausible to you, and then we can bounce them off each other and say, oh, that would work, or no, it won't work for this reason.
Okay.
And like I said, the goal is not to eliminate pain. The goal is to maximize the utility of the pain.
Perfect.
Right?
All
Okay.
right.
Have a good one. Talk to you soon.
Thanks.